So we want to calculate the volume for each of these shapes. So looking at this first prism, what type of shape is that? The hexagonal prism or hexagon. So my base is going to be a hexagon. If we look at a reference sheet from yesterday and the week before, we know our volume is our base times the three-dimensional height of your shape. So that three-dimensional height is whatever it takes you to get from one base, or the distance from one base to the other base. And so depending on how your base or how your shape is oriented, that height might not be vertical, it might be horizontal like it is in this first case. It's going backwards 8 feet, right? But it's just that distance between one base to your other base, or from your base to like the top of the cone or pyramid, if we're talking about those. So step number one with these prisms is we need to find what is that area of my base. And so because we have a regular hexagon, because it's our regular shape, we're going to have to use that regular formula that we talked about last week, which was the 1/2 times the side length times the opossum times the number of sides.
So why would your base be a rectangle?
So our base is it's always that shape that's like that defining shape that is, at most it should only happen twice, unless it's a cube, and I guess a cube, but that's a different story. So your base is sort of that the shape that defines what the prism looks like. So if it was a rectangular prism, all of our sides would be rectangles. You're always going to have either a rectangle or a square that's going to connect your bases together, and that's what these all are. The reason is that this base is on the bottom is just because we took that purism and we sort of flipped it up onto its side. And so our bases are going to be the hexagon because that's sort of the defining special shape inside of it. It's only when we have a rectangular prism or a cube is when that top and bottom or any of the sides don't really matter for the bases because they're all rectangles in that case. But if it's any other type of prism or any other shape, it's whatever that shape that isn't the rectangle, that's going to be your base. Was that an okay example? All right. So our area of our base is 1/2 the side length times the opossum times the number of sides. So what is my side length for this shape?
7.
7. What is my number of sides, or what's my opossum, I'm sorry? And then our number of sides, because it's hexagon, is 6. So if we multiply all of this stuff together, we should get 127.06, and then because all of these are feet, I'm going to put it in feet squared because this is just the area of my base so far. So that's just the area of our base. But once again, our formula for volume is base times height, or area of our base times height. So in order to get the total volume, we just have to take 127.06 and multiply that by our height, which is just 8 feet back. And remember, the height, the reason we use this formula is because our volume is you're like stacking that area on top of itself. You're taking a slice and you're putting another slice on top of it, another slice on top of it, another one, all the way up until you get that total volume. In this case, we're sort of stacking them up and we're going back 8 feet until we get to that. So we'll multiply by 8, and that answer should be 1018.08. And this is feet cubed because we're talking about a 3-dimensional volume. Are we okay with that? Seem familiar from yesterday with those formulas? What was our cylinder formula that we talked about yesterday? How do we find the volume of a cylinder? Good. Pi r squared times the height. So the reason there's a difference between these two, even though they're both technically prisms, is because the base of any cylinder is always pi r squared. It's not going to be changing. It's not going to be potentially a triangle, potentially a hexagon, potentially an octagon. It's always a circular shape, so it's always going to be pi r squared. So that's why we can just easily combine it into one set compared to 2. What do you notice about this cylinder, though? They give us our diameter. So in order to get that radius, we just have to cut it in half. So 14 divided by 2 is 7. And then we can do our volume is pi times 7 squared times our height of 15. We multiply all that together and we get 2,309.07. This is millimeters cubed because it's a volume. We okay with this? Seems simple, seemed easy from yesterday. And then yesterday we did the cylinder cup things. All right, so today our goal is just to talk about the other three. We're going to talk about pyramids, spheres, and cones. Starting, we'll do pyramids, cones, spheres. Will be the order we'll do it. Pretty simple, pretty much the same thing. Same sort of easy steps. It might just be one or two extra steps depending on how we have, what the shape gives us. What is our volume formula given to us on our reference sheet for a pyramid? So 1/3 base times height. So volume equals base times height. That was our formula for our prism. The reason we have that 1/3 in there is because the reason we got that base times height was because you were doing those stacks. You were to do a stack on top of another stack, on top of another stack, on top of another stack. The reason we have this 1/3 in here, though, is because as we stack up, these stacks are getting smaller and smaller and smaller and smaller, and these areas are getting smaller and smaller until it just becomes a finite point. So we're losing 2/3 of that volume as we increase towards the top. Don't worry about how we actually calculate the 1/3. That's just sort of the number that comes in there. But as you get small, as you're stacking smaller and smaller squares on top of itself, you're still using that same base, but it's decreasing in height as it gets closer and closer towards the top. So that's why we have the 1/3, because you're only getting 1/3 of that total prism's volume through the pyramid.
The vertex of the apex.
We apex, I think. Trying to remember that name. Vertex is like an angle. So I guess if you're looking at like this angle right here, that would be a vertex. I think apex might be the right word, but I'll have to check that. I'm not positive on the direct definition for that point. Good question though. So in order to do this, all we need to know is the area of the base and the height. Multiply that together, and we're good. So because this pyramid, my base is a square, in order to find my area of my base, it's just 16 times 16, which is 256, I think. Let's get my notes out. 256. And then our height, we're told, so with these pyramids, we're no longer looking for slant height. We're no longer looking for that height on the outside. We want to know that three-dimensional height from the bottom of the pyramid to the top. Just like we had a three-dimensional height for prisms. And so I need to know, okay, what is that height from the bottom of my base to the top, which is 6 in this case. So our volume is 1/3 times our area of our base, which is 256. And then times my height, my vertical height of my pyramid, which is 6. So 1/3 times 256 times 6. Multiply that together, and we should get 512. And then we have feet cubed because we're. So pretty simple, pretty easy. 2 steps. Find that area of my base. Multiply by 1/3 of my height. I'm good to go. Think you can try the second one? All right. Someone walk me through what they did for this problem.
So I started with like my base, and then I did 6 times 6 side thing, and then I took the b equals 1/3 times 76 times 4, which is the height of the b, and I got 48.
48 meters. Good. So once again, 4 is going to be your height. The 3 they gave you is just extra information. We didn't need that to solve the problem. We don't need it at all. So sometimes they might give you extra information on these problems that you don't actually need, that we don't care about. And with those, you can just typically just shove it off to the side. Sometimes we might actually need those measurements in there, though, in this case. But 48 meters cubed should be your area of your base. Okay with this? Area of a square pyramid? Not area of a square, volume of a square pyramid. So we have square pyramids. Sometimes we also have those regular pyramids, those ugly shapes on the bottom that have those same sides. But just like with our prism, we're still using that formula, the 1/3 times the area of my base times the height. With these, though, we just have to take a little extra work for that area of our base. we just had that longer formula, which was the 1/2 times the side length times the apothem times the number of sides, which in this case is 1/2 10, which is our side length, times our apothem, which is 8.66. And then times the number of sides is a hexagon that I have, so I'll times it by 6. Do all that together, and we should get, let's see, 259.8 feet squared. And that's just the area of my base. That's just my big capital V I have so far. I also need to multiply by 1/3 and multiply by my height. What is the height of this pyramid?
14 feet.
So 14 feet is my slant height. What's my three-dimensional height? They didn't give it to us. So in order to solve this, we're going to need to do the Pythagorean theorem. So if we were to cut this triangle in half, 14 feet is your outside. From the outside to the center is your apothem. That's your 8.66. And then our height is your other missing side of our triangle. So using our Pythagorean theorem, we can solve for that missing height as well. So that would be 8.66 squared plus h squared equals 14 squared. We're going to do that Pythagorean theorem a little bit. 8.66 squared. If you square it, it should be like 74.9956. So if we round up, it should be 75. Plus h squared, and then 14 squared is 196. Subtract 75 to get h. And we get h squared to equal 121. And then last step is just our square root. Square root of h squared, square root of 121, h equals 11. So because we're looking for that vertical height, we can't use that normal three-dimensional, we can't use that normal slant height like we were doing last week. We have to figure out what is that three-dimensional height from the base of my pyramid to the top. And so that's why we had to do that Pythagorean theorem. So once again, it's the apothem is that distance from the outside to the center. The slant height is your hypotenuse, and your height is going to be that vertical side of your. So we're just using a squared plus b squared equals c squared. So square those values, subtract them, take the square root for h, and you should get h equals 11 in this situation. And now that we have all these pieces, we have our base, area of our base, we have our height, we can find the total volume. Our total volume is 1/3 times the area of my base, which was 259.8, times my height, which is 11. And this total solution should come out to be 952.6 feet. Sorry, because it's the volume. Okay on this? Questions on this? Confusion? So this one, it took a little bit more work because our area of our base is a little extra. It takes a little extra to do that. We had to solve for that height using Pythagorean theorem, so we had to do a little extra work from that. So rather than just being like a quick two-step like our last one was, we had to do a little bit more steps involved with this one to be able to get those pieces that we need. So I want you to try to figure out, okay, what is the area of your base for your second pyramid? Use Pythagorean theorem to find your height, and then multiply it together to get that volume. So see if you can do the same steps and mimic for that second one. So using our same area of our base formula, 1/2 times your side length times your area, or times the apothem times the number of sides, we should get our area of our base to be 110.2 centimeters, I believe. And then using Pythagorean theorem, your 5.51 squared plus your h squared equals 10 squared. Solving for that, you should get your height to equal roughly about 8.3, 8.4, somewhere around there. from what I remember, 8.35-ish. And then multiplying it together with your volume, 1/3 times your area of your base times your height, we should end up with about 306, right around there, centimeters cubed. Seem okay? So once again, there's just a couple extra steps in this one because we had to solve for the height, we had to solve for the area of that base. It took a little bit longer to do those things, but it's still same steps, still the same process as with last pyramid. So nothing too bad. So if we flip over, we move on to our cone. So the cone is technically still a pyramid. So we technically still use our volume of 1/3 or equals 1/3 times your base times your height. But the thing is, because that cone is always going to be a circle, and because the circle's area of that base is always going to be pi r squared, our cone formula can just change to 1/3 pi times your radius squared. It's my pen will stop. So really, we just replace that big capital B with pi r squared because they're the same thing. But same formula, same idea. Except now we can sort of, as long as we have that radius and as long as we have that height, we can do it in one simple step, one easy step. So that first one, we have both those pieces of information. We can do 1/3 times pi times your radius, which we're told is 9, so 9 squared, and then times our height of 12. So just plug all of that information into your calculator because we have it already, and that should give us a nice 1,017.88 centimeters cubed. So it's really easy, really simple when we have all those pieces just plug in. What do you notice about that second cone though? They gave us a diameter instead of a radius, and they give us a slant height instead of an actual height. So, what can we do?
Oh, actually no. So you have to do like Pythagorean theorem, but like your 5.5, which is half of 11, is at the bottom, so you're solving for.
So the first thing you did was you found the radius by cutting 11 by 2 to get 5.5. And then we can see our right triangle. So we can use Pythagorean theorem to solve for that missing side. So your 5.5 squared plus your h squared equals 7.2 squared. So solve for your h. We have our radius. So see if you can find the total volume once you get that height. Okay, so we should have had our radius come out to be roughly, our radius we cut 11.5, our radius should be 5.5, like we said earlier. Our height using Pythagorean theorem, you should get something like 4.65, depending on how you round it and things like that. And then your total volume should be something right around 147.3 feet squared or 3 feet cubed. Once again, that might change depending on whether you use 3.14 or whether you actually use the pi button. It might change depending on what your height was or how you rounded with those things. And so as long as you're close to that number, as long as you're within that typical range, so as long as you're within 146 to 149, you're probably good. You're probably in a solid area. So once again, we're always trying to get within like just a few decimal places or just a couple points within that range that they give you depending on the rounding. So if you're, as long as you have close to the exact number. Seem okay? So spheres is the last thing, and spheres are really easy. They just have one formula, just one step, which is volume equals 4/3. 4/3. I don't know. Oh boy. Okay. Let me try this one more time. Volume equals 4/3 times pi times your radius, and then it's to the third power cubed. This is our volume formula of a sphere. And so because it's just the radius is the only thing we need, typically these are going to be pretty easy to solve. So as long as you know that radius, you can just plug it in and you're good to go. So for that first one, it's our volume of our sphere is 4/3 times pi times our radius cubed, which our radius in this case is 6. So 6 to the 3rd power. For putting these powers into the calculator, I know those of you who like to use the square button, or the x squared button, for putting to the power of the 3, if you look right above the divide sign, there should be a caret. And if you hit the, actually, your button. Okay. On those smaller calculators, if you look right above the x squared button, there's that caret symbol, that little up arrow. So if you hit that and then hit 3, that will raise it to the power of 3. So you can do 4 divided by 3 times pi times 6 caret 3. And that should get it to the power. And that total answer should be 904.78. Then this is centimeters cubed. That volume of that sphere. And so, if you want to do the other one, all you have to do, determine what is your radius, and then see if you can find that final volume. So in this question, we see 20 is our diameter, so 10 is our radius, so we have 4/3 pi times 10 cubed equals our volume. So our final answer should come out to be 4,188 point something 0.79 inches cubed. Inches cubed. So those are our 3 other volume formulas for today. Those are our 5 in total that we talked about between today and yesterday. So tomorrow, we're going to talk about composite shapes. So what composite shapes means is it's basically 2 shapes put together, or multiple shapes put together to form like a new random shape. So that could be like a box with a cone on top of it, or a sphere with a cylinder coming out of one side, or something like that. So we're going to learn how do we find the volume of these shapes that are made of multiple ones. And really, it's pretty simple. We just have to, find the volume of this piece, find the volume of that piece, and add them together. That'll give you your total volume. So it's really just remembering, how do I find the volume of the cylinder? How do I find the volume of the sphere? How can I put it together to get a total volume of something together? So it'll be a little bit extra. There will be a little bit extra work to it, but it's not too bad. It's just really using what we've already talked about and then just doing 1 or 2 in a row and putting it together. So nothing too difficult. Once again, I won't be here Friday due to my meeting thing I have to do. The goal is still to take the assessment on Friday. I think you should do fine. I'll try to leave practice or something like that for you to be able to do a little practice together before the assessment. If you want to work in groups or work with a partner or something like that, or practice as a class together, do some problems together, that's fine. And then I'll have the study hall monitor, or not study hall monitor, that's terrible. The sub do the, have the assessment start halfway through. So I'll figure out what to do for that, but I will not be here Friday. If you have any questions over the assessment, try to potentially ask the sub. If it is someone like Mr. Rapp, he's typically pretty good with stuff like that. If not, I'm fine with you asking the whole class, hey, does this represent a diameter? Does this represent a radius? Is that slant height? Or if you're confused on a measurement or something like that, try to ask the whole class or something because I feel bad that I won't be here to be able to answer those questions. And if something's really bad, all the numbers are wrong or something, then we'll reconvene on Monday and we'll figure out what to do from there. Sound good? Awesome.